In 2007, a strange headline shocked the world: the mysterious case of the white-collar worker without a brain. On the outside, a normal 44-year-old man, employed, married, with 2 children, and an IQ of 75. And on the inside, a gaping, fluid-filled cavity where a brain would normally be. And he's not the only one. Stories like this keep making headlines. People living otherwise regular lives, but underneath the surface, nothing. How do these stories challenge our understanding of how the mind works? And how would you feel if you found out you had no brain? Today we explore the mystery of how consciousness can exist without the brain, and how the structures of music might offer a radical new perspective. Welcome to Ideas for Our Time.
We choose to go to the moon.
There are things we thought we knew and don't know.
And it's one of the things we're hoping to discover.
I have a dream today.
Today's idea comes from Michael Gazzaniga and Bridget Queenan, 2 distinguished neuroscientists. This video is based on an article that they wrote for our website, which you can find the link for in the description below. Michael and Bridget propose a new way of thinking about consciousness, not as a physical phenomenon, but as the music of the mind. Along the way, we'll hear directly from Bridget, who was kind enough to let me interview her about this idea of theirs, and how it could shed light on the matter of artificial consciousness.
I sort of trust that if anyone is going to figure out how life works and nervous systems and brains, it would probably be musicians. Like, my money is on them.
But first, the missing brain. The case of the missing brain is rare, but not unique. Outside of the headlines, there have been many studies examining these instances of people missing most of their brains. Often these people go into hospital for other reasons, and only then does a scan reveal that they just have a thin layer of cortex, the rest of their skull filled with fluid. In these cases, it's a surprise that these people have been going about their lives fairly normally, all while lacking so much brain matter. Even rats with hollowed-out brains have been shown to perform well at various tasks. Importantly, if you're born with no cortex, things look pretty bleak. Infants born with hydranencephaly rarely survive longer than a year. But these cases of having barely any brain reveal something quite extraordinary. If you were born with just 1/10 of your liver, you'd have a serious issue. But somehow the brain can handle it? We know what brains are supposed to look like, and these brains just don't look right. Our nervous system, the brain, the spinal cord, and the brainstem, float around in cerebrospinal fluid. Our brain should have a few ventricles, but not ventricles that big. A normal adult skull has a bit of fluid in the center and around the edges. The rest is brain matter. But the skulls of these individuals are mostly filled with fluid, with just a little bit of brain matter at the outskirts. It's like the central ventricles have overflown completely, which is actually something that can happen in adulthood, a condition known as hydrocephalus, and it's bad news. The skull fills with excess fluid, which impairs behavioral, cognitive, and motor functions, and to prevent serious damage, shunts have to be installed to drain the excess fluid. But in these cases, if the initial brain-to-fluid ratio is different, somehow it works just fine. It's just a different arrangement. The big question here, of course, is how does consciousness work if you have so little brain? Neuroscience has been trying to solve the problem of consciousness for a long time. According to Michael and Bridget, it might be time to look at the problem in a whole new way.
In a field that has been stuck for a minute, if you're stuck, you might as well just start playing around with ideas, and then you'll get there faster. And you have different waves of a technological revolution where you're like, okay, now we're gonna crack this thing right wide open, right? And so, when you couldn't look inside a human brain, people did phrenology, right? So you're like, what information is available on a skull? That if that's the best you can do, then that's the best you can do. So might as well start with that. Certainly when all the structural brain imaging came into play, that obviously you could do CT and X-ray and MRI. And then it's like, okay, now that we can look inside brains, can we do this voxel-based morphometry? Can we see if this brain area is larger or smaller? But then once the functional imaging came into play, where you're like, we can have PET scans and we can have, bold signals of where the oxygen is and various things, there was the sense of okay, we can see inside a living human brain. So this will be wrapped up in, a couple weeks. So you get these sort of surges of all right, we're going to figure this all out. And then, it's just how science works, is everyone does their homework. And then at a certain point, you exclude all of the reasonable things. And then you're like, well, those didn't work. So like, what's the next idea, right?
Let's begin by comparing music to brain activity. Both of them could be described in terms of volume, the amount of sound happening at once, or the amount of brain happening at once. But the volume of music is not the sole determiner of what makes a good song, unless we're talking about the loudness war, but that's a story for another time. There's also other components, like the rhythm, the harmonies, the melody. Music is the elaborate interplay of these different frequencies, which in combination creates something beautiful. Now consider the brain. Once again, the volume might not be the sole determiner of what makes a brain good. There's also the circadian rhythm, the central pattern generators, and the real-time brain activity. The conscious mind is the elaborate interplay of these different frequencies, which in combination produces something beautiful. In both cases, volume is the easiest thing to measure. In music, it's hard to quantify rhythm and very difficult to quantify the melodies and harmonies. Same in brains. For years, neuroscience has found better and better tools for measuring volume, but it's hard to quantify the circadian rhythms and very difficult to quantify activity from firing neurons. In both cases, volume only tells you part of the story. Now, how does this musical analogy help us think about these brainless patients?
There's a lot of people who've been put in scanners where like, yeah, there is clearly a certain shared layout. Yeah. The same thing as an orchestra where you're like, yeah, we put like, it's not random that the big instruments are at the back, right? Someone thought this through. And so you're like, yeah, you sort of expect timpani to be in a certain place. And so there are reasons why it's set up this way. There's reasons why it works this way. And so if you go to hear a symphony, yes, you should reasonably expect that the cellos are going to be where the cellos are. And so I think that's a healthy way to be thinking about brain structure.
What Bridget means here is that we can kind of think of the brain like an orchestra. The brainstem is the conductor, and in vague semicircles around the conductor, you have the hypothalamus, the thalamus, the basal ganglia, like the different sections of the orchestra. And then the largest arc at the back is the cortex, like the choir at the back of the hall. That's what Bridget means about a shared layout. Neuroscientists have used modern brain imaging to figure out the brain's orchestral layout. Language is here, vision is over there, memory over in that section. But our friends without a brain are like orchestras without instruments, just a conductor in the middle and a small choir at the back.
So I think it's just like a healthier way of being like, yeah, of course, you have a genetic program that unfolds, and if everything goes well, you sort of use the thing that worked before, and that's great. But it's not deterministic. It doesn't have to be that way, right? If you only have 5 people up on stage, then you're gonna play the song with those 5 people. I went to see like a chamber group do Beethoven's 5th and 7th. It was great, they know what they're doing. Obviously, someone had to put some effort into distributing a symphony for, 80 people onto 4 or 5. So it's not to say it doesn't work, but you can't tell me like that's not Beethoven's 5th symphony. It's recognizably Beethoven's 5th symphony. And so the thing that made it recognizably his symphony wasn't the number of people playing it.
We've now seen how using music as a metaphor can provide new ways of exploring the mysteries of the brain. But can music be more than a metaphor? And is there something that musicians know that we don't?
I sort of trust that if anyone is going to figure out how life works and nervous systems and brains, it would probably be musicians. Like, my money is on them. It's like if they've figured out how to mathematically interrogate a world that's entirely invisible to us and like make these insane calculations on the fly, you're like, I would put them in charge of wave physics. I'd put them in charge of a lot of stuff, like they seem to know what they're doing.
Michael and Bridget push this idea further and explore what it would mean to define a basic layered hierarchy of consciousness based on the rhythms of the body that we observe in others. Instead of consciousness being a thing that you have or don't have, they define it using a musical hierarchy, starting with the minimum requirement for life, that the brainstem keeps time.
I mean, we already know that it's like if your brainstem is not involved, that's the end of everything. So I think building from the brainstem back up is a healthier way of doing it than starting from our highest order cognitive processes and working back down.
Without this tempo, you are brain dead, no music, the lowest level of the hierarchy. One step up, you get asleep. With the tempo set by the brainstem, you get a simple polyrhythm consisting of the heartbeat and the breath. Now we have awake, a complex polyrhythm, where we add in blinking and limbs in motion. The body now has a whole rhythm section, and the pace has increased. Finally, we have awake and aware, a complex polyrhythm that changes and evolves in response to stimuli. In musical terms, a band that can improvise. Now, building up a hierarchy from the minimum requirements like this is interesting and a very different way of thinking about consciousness. Crucially, it's a very broad definition, one that admits more than just humans into the consciousness club.
If you're just talking about basic theory of mind, of like, do you understand that this other creature has a mind that is not yours, that you could anticipate? You're like, I know plenty of dogs who have higher theory of mind than, colleagues of mine, right? Like, it's like, they clearly understand that you're like, yeah, you're you and I'm me. And like, I want the thing that you have. And if I do this thing, it will be more likely. So to me, it's just like, it's pretty clear. There were some crows that I used to feed at UCSB in the parking lot, and they wouldn't eat the food unless I first ate it, and then they would eat it. And so you're like, they're in the club.
That's theory of mind.
Clearly in the club. I was like, that's more sophisticated than a lot of people to just be like, we are not falling for this one. We are not getting poisoned again.
At the physical level as well, you mentioned phrenology. Throughout history, people have tried to find ways that the human brain is more impressive than every other animal to show what sets us apart.
For me, one of the things about there's like an alarm bell that goes off in my head with certain people, how they talk about consciousness, where you're like, this is just a eugenics kind of thing that we're doing here, right? And you're coming in determined to find evidence that certain people are in the club and certain people are out of club, and I already know how this goes. We have already done this simulation. Like, you did it with women, you did it with Black people, you did it, like, you're doing it with animals. So just, that is not science. If you're building it from the ground up to just say, okay, what is the minimum requirement? Everyone who meets this requirement is on level 1. Okay, now what is the next one? Level 2. And so that is if you're doing it as a bottom-up approach, then you're actually interested in what are the features that are shared? And then that helps you figure out, okay, now what are the features which differ?
There is a stunning history of humans trying to find ways of scientifically defining our superiority over other species, especially when it comes to consciousness. Yet, again and again, the physical characteristics of our brains do not seem to set us apart. Not brain mass, not brain density, not the number of neurons or the number of folds. According to all of these metrics, humans are not remarkable. So, to fulfill this agenda of ours, we turn to things like language to set us apart. This thing that only humans can really excel at. Right?
The arrival of artificial intelligence.
Artificial intelligence.
Artificial intelligence.
Artificial intelligence.
Michael and Bridget's definition of consciousness has nothing to do with language. In the musical metaphor, lyrics are not the same as music. And so language is not the same as consciousness. You weigh down very heavily in the article on kind of admitting animals into the consciousness club and kind of turning down language, which some people argue is very much what sets humans apart and then maybe is what makes us conscious rather than animals. So do you think it came from this idea that if we want to exclude AI, which is this thing that is very good at language but doesn't have those physical characteristics, is this an idea of how we can redefine consciousness?
Yeah, I mean, I guess probably in my musical definition, none of those systems are going to meet the requirement for consciousness because, it's going to be much more based on sort of physiological rhythms and variance. And also, what are the minimum resources you need to produce the maximum thing? Originally, I was a biochemist. So biochemists are like the economists of the science world, right? It's like, how much can you do for how little energy? And so you're like, living things are so interesting to me, where you're like a handful of Skittles and I can solve all these math problems, right? I just need coffee.
Yeah.
And whereas you're just like, yeah, sure, if you need to drain the entire Colorado River and start a nuclear power plant, I don't actually think that's impressive. I think it's really cool that you can do this on the fly. Well, and I guess that's part of what's so interesting about those folks' brains, right? Is it's if you could get all of that cognitive performance out of just this, good job, you. I don't think we should be making fun of these folks.
Yeah. Wow, how amazing a structure that with a like tiny amount of brain mass that you can achieve all that. Perhaps this alternative definition of consciousness, built up from physiological rhythms, can help separate man from machine. Or maybe consciousness shouldn't be our main concern when it comes to AI. Are you worried about the effect that these systems will have on our brains and the brains of people who develop while using all this technology?
Yeah, absolutely. Because I think that one of the things that people have forgotten, and a lot of my neuroscientific colleagues, this would also be true, is the nervous system is also neck down, right? Like, this part is great, don't get me wrong, I love it. But like, this part also is involved. Your conscious mind is for problems that you haven't solved yet. But every time you solve a problem neurologically, you move the solution to a different part of your nervous system, right? So like, once you know how to ride a bike, you don't have to think about it because the knowledge lives in the basal ganglia, right? You know, the knowledge of how to breathe and beat your heart is not conscious. And so I think that's also like, if you spend all of your time, you know, kind of in your conscious mind, you're spending all of your time with your failures, right? By definition, like, this is all of the stuff on your to-do list that you haven't done. And so you have to spend time with the activities where like you did already, like learn to walk and learn to ride a bike. And if you're only consuming music or you're only consuming art, then your nervous system has no opportunity to do what it likes to do, which is to experiment with, you know, with music, with sports, with painting, you have to physically implement it. And or just walking around, you're testing your hypothesis of where the ground is. And every time you step, you're like, good job, me. Like, like, I got that. Like, you do it your 1,000 steps, and every single time you got that math problem correct. So yeah, so I think that the more you're divorcing people from their kind of physical interactions with their environment, the more crazy you will drive people, just because your nervous system that's what it's interested in doing, is kind of confirming these physical hypotheses about the world. And if you're starving it for things to do, then, you know, yeah, you put it in like solitary confinement. So of course it's going to go a little crazy. So yeah, I do think that it is a recipe for insanity if you don't let yourself do these things. And I mean, I guess that's why I'm sort of naively hopeful that one of the things that you know is emerging and could emerge more with the AI conversation is, like, I understand that we're outsourcing the creation of music and art to these things, but that's assuming that art and music are just things to be consumed, right? And that the whole point of some of these activities are like, no, they are actually things that you do, right? Because the process of doing them is the thing, right? Not the product at the end. And so of necessity, you have to make a product that you can sell because you live in a capitalist system that has required it of you. But that wasn't the point of it, right? Like, if money was no object, you would do it because it creates meaning.
To end my conversation with Bridget, I wanted to ask her more broadly about how music should be treated within the scientific community.
I do sort of think that, you know, modern scientists don't realize that obviously there are certain things that we have that are so amazing and we are in sort of a golden age. But there are other things where you're like, no, this really is a dark age of science because you've kicked all of the arts and humanities out. And that's a fairly recent development where you just ripped the heart and soul out of the scientific enterprise. And so, like, it's going to lead to evil, but also just like, it's not going to be fun. Like, you know, just like, it can't be fun. It has to be like, it's not a human enterprise. It's a creative profession, right? It's just like wondering about the world and experimenting with the world and drawing pictures of the world and describing it in numbers. I mean, it's supposed to be an art form. And that's why I like kind of using Planck or Newton to just be like, okay, these are people that you respect, and like, they didn't look down on arts and humanities, you know.
Today we've explored the mysteries of consciousness through the lens of music. We've seen how thinking about consciousness as the music of the mind not only helps us understand these cases where the brain's structure is radically different from the norm, but also helps inspire new definitions of consciousness that bring us closer to our animal friends and further from AI. The beauty of music is an emergent property that cannot be easily explained by its components. Maybe consciousness is the same, a beautiful emergent property that can't be explained by physical measurements. Perhaps there is still a lot we could learn from musicians.
People with dementia, like they've forgotten everything else, right? Like they've forgotten their partner, they've forgotten their kids, they've forgotten their names. But, you know, when you see the footage of pianists kind of coming back to life and performing, or ballet dancers, I mean, that to me is just like, if that's the last thing to go, then it's probably the first thing that you build.
Thank you for watching Ideas for Our Time, and stay tuned.